Alright, so this is a second method in evaluating logarithms in an alternative way. This is not as conventional, but it utilizes the definition of a logarithm. Let's go back to it here. So we know, actually let me just copy it here so we can bring it down. Let's change the color. There we are. So we know that we can go from the index form to the logarithm form, but we should also be able to go backwards, which is what we're going to be doing for this method. So we have log base 2 of 16. What we do is let that equal x. So going backwards from here to the index form, this becomes 2 to the power of x equals 16. And this is what we've seen before in term 1. This is 2x equals 4 squared. 2x equals 2 squared all squared. 2 to the power of 4. And we can see just by observation, therefore x equals 4. Same case here, you can actually just let this equal x. This becomes 8, so following this again, this becomes 8 to the power of x equals 8. And by observation, x is equal to 1. So this must equal 1. Same case for this one, although it will be slightly more difficult. Let this equal x. This will become 5 to the power of x equals, I'm going to change this straight away into index form. This will be 5 to the power of negative 1/3. And by observation, we can say x is equal to negative 1/3. Same case for this one. Let this equal, we can actually let it equal any letter that we want, equal a if we want to. So this will become 15 following this again. That's 15 to the power of a is equal to 1. Well, anything to the power of 0 is equal to 1, so a must be 1. So here's where it gets slightly more difficult. Let's bring this back down so we can keep looking at it. So for this, we only let this portion equal x. Okay, so we're going to do a little sub calculation off to the side. Let's do this in a different color. So this becomes 5 to the power of x is equal to 25. 5 to the power of x equals 5 squared. And by observation, x equals 2. In this solution, we substitute back. So this becomes 2 plus the original one equals to 3. So all of this is equal to 3. Same case for this one. We only let this portion, so this will become log base 3 of 27 is equal to a, or whatever letter we want. This becomes 3 to the power of a is equal to 27. 3 to the power of a is equal to 3 times 9. 3 times 3 squared, which equals 3 cubed. So 3a is equal to 3 cubed. And so by observation, therefore, a is equal to 3. Substituting that answer back in to this one, this becomes 4 times 3, which equals to 12. one last one here. Whoops. Again, a little sub calculation of this one. That's log base 4 of 64. Let that equal, let's make it y just to be a bit creative. 4 to the power of y is equal to 64. 4 equals, that's 16 times, no, sorry, 32 times 2. There's a y there. 32 is 16 times 2 times 2. Oops. Which is 4 squared times 4, which equals to 4 cubed. And so by observation, we can say, therefore, y is equal to 3. And then now substituting 3 back into here, this will give me 3 times 3 plus 5. That's 9. That's 9 plus 5 equals 14. So I hope that gave you an alternative method in evaluating logarithms using basic logarithm laws. In this second method, it's not as conventional. I do highly recommend that you learn this one first before going to this one. Hope to see you in the next video. Best of luck.